So today we'll be looking at a tennis refactoring kata. And actually we're going to start with the first part of that, just trying to cover the functionality with test. Oftentimes when we're working with legacy code and we're trying to introduce refactoring and even testing, or maybe TDD, it's hard to know where to start. So I'm going to show you something today called Characterization Test, and we'll see how we can take the behavior of the existing code and build a test suite that we can trust. Let's start off by defining legacy code. So in Michael Feather's book, Working Effectively with Legacy Code, he describes legacy code as valuable production code that does not have tests. This kind of code is hard to change, and developers often fear this kind of code. There becomes this attitude of don't touch it. It works. Don't touch it, don't break it. But having comprehensive tests that preserve that behavior can be a huge asset when you're factoring and improving the design of your code. And it makes you want to do that more often because you feel like you'll make less mistakes because you have this safety net of tests that you can trust. So you know when you'll make mistakes right away. So let's look at this in our software crafting series. We'll start with adding tests to legacy code. So on the left, I have the tennis test. On the right, I have the tennis game. So let's explore the existing code. So we instantiate it by passing two names in. We'll see that these names aren't actually used anywhere. We have this public method, 1 point, and get score. Those are the only two. So get score seems to be returning some kind of builder. So we build like this scoreboard over time, and players accumulate points. So we have a name and a score. So we're not going to really focus on improving this code because we can't really refactor this until we have tests. And that should always be the attitude that you take. You first need to cover your functionality with tests. We're going to look at a concept called characterization test. So I don't want to have to go through and figure out everything. I'll just say when point, this first if block is if they're equal, and then this seems to be some kind of advantage play, advantage, and then when else. So we can actually just see if we initialize the game and we get the score right away, what happens? It's pretty simple. So let's start with that. So we'll actually call this starting score. So by writing these tests, we're going to find out what the current behavior is. So we'll say assert that score. And today we'll be using assert J, fluid assertions. Without anyone winning points, what would the initial score be? This is our first characterization test. Now, as you can see, I've put a null in the expected value. So if we look at assert J, we have assert that actual, is equal to expected. Now I've got the output here and it says that it's love all. So I can actually just take the output and put it there, rerun the test. And by doing this, I let the code tell me what its behavior is without really having to think about anything. A good aid for characterization test is to have the line coverage. So we basically want roughly 100% here, and then we know we're fully covered. So we're at 6% now. We're just looking at line coverage. Actually, we want to look at it right here. We're actually at 27%. And IntelliJ can actually see this green bar. It means that these have been executed. These paths have all been executed. Let's stick with this for now, and we can have another test here. Both players score 1 point. That's the behavior. And what would the output be? Again, we'll put null before we get the score. Let's say 1 point, player 1, and 1 point, player 2. Okay, and now we get 15 all. So again, we'll take this and we'll replace it. Okay, so what happens when they score 3 points? Okay, and we get tennis deuce. Okay, and I think we can check in on the test coverage. So if we look at the test coverage now, we're up to 47%. We're almost halfway there, actually. So we've covered all of these blocks, but we haven't really touched this or the else case. Before we move on to that, let's look at some of the duplication we have. We could potentially move this up. When you're writing unit tests, one concept you should be aware of is damp versus dry. Damp stands for descriptive, meaningful phrases, while dry is don't repeat yourself. So in test, you should favor descriptive, meaningful phrases over don't repeat yourself. Duplication is okay in test. Now, sometimes you may want to maybe abstract a parameterized test, which we may look into doing today. But what's really important about tests is that they serve as documentation for your code's behavior. They tell the user of your software how your code works. So it's really important to really illustrate that in a meaningful way. So when I read this test, starting score, I think that makes sense. Starting score, maybe initial score. So maybe I'll rename this. I'll say initial score. So I do see one duplication that we can pull out. I don't think this is going to change much. So why don't we pull this out? We'll say private final, and we'll have that there. And then we'll run the test. So when we make refactors like this, we always want to run the test after. I'm going to run these tests often. Okay, so now how can we get some descriptive, meaningful phrases? So game that gets score. That makes sense to me. And then we have assert that score is equal to love all. That makes sense as well. Now, what about this other test? We have both players score 1 point. I think that's a good test name, but I do notice some noise here. So I think we may be able to craft something a little bit. So let's look at this, for instance. Is there a way we can say how many points? Maybe instead of saying that player one won a point once and then twice, maybe we can just add it up and accumulate it. So you should be able to remove this or run just this test for now. That passes. So let's call the same thing here. And if you're curious about my shortcuts, they should be popping up at the bottom here. Okay, so I like to have my helper methods at the bottom here. And now we'll replace this. And this should help us a little bit going forward. All right, now we can jump to the next block here. Let's call this advantage. So we can get to this case if we have at least 4. So we want somebody to have 4 points. And I think we'll have player 1 have 4 points. So what happens if we have 4 for player 1? Player 2 has 3. Okay, and now we get advantage player 1. Now, it is a little bit obvious in this scenario, like how these are going to go. Just imagine that you were in a complicated code base where a lot of things are happening. This kind of testing can help you determine the behavior of your code. Let's see. What is changing between these tests? We may be able to parameterize this test at this point. Let's try that. So now we have parameterized test. What do we have here? What changes from test to test? Well, initial score is kind of unique in that it only has an expected. So we can actually bring this out and say expected. Let's say expected score. Expected score. And we can put that in the setup. And we could potentially do that with all of them. Now, how would we parameterize this? We have an expected score. We also have how many points. So let's do it like this. 1, 1, 15 all. So let's just try to get this one working here. Let's try this. Okay. Now we can also enhance this a little bit. So now we can actually remove this test, and now we can parameterize the rest of these. So adding tests should be super easy now. Okay, there you go. And we can get rid of this one too. Now let's revisit our test coverage and keep moving along. All right, so now we're at 59%. If you look at our red and green bars, we need to do advantage player 1 now. Think keep our same pattern here. Just do this. Still get a characterization test here. So yeah, we have null as a string. Doesn't really matter what you put. We just want to take the output. All right, win for player 1. That looks to be like if player 1 has 2 more. So win for player 1. And then we have a win for player 2. And at this point, I kind of already know the behavior. So I'm just moving through this. Now, if we're in the middle, we're not tied, we're not here, what would we look like? Let's just not really look at the code and just say what happens when we're 1 and 2. 15 and 30. I guess for this one, we want to cover all these cases. All right, now let's see what our coverage is now. We have 100%, look at that. So what have we done today? We've taken some code, previously had no test, and by using characterization test, we fed the method some inputs. We would pick who won the point, and we'd figure out what would happen. Now, this code wasn't overly complex, so we were able to most times kind of figure out what was happening anyways. But when things are really complex, to get that kind of feedback and to really get the true behavior of the code is important. So when you're working with legacy code in the future, you can use this technique called characterization test to help you to cover your behavior with tests so that you can go ahead and refactor it. Next time, we're actually going to refactor this code. Now that we have the test, now we'll see just how valuable these tests can be. If we make a mistake refactoring, we're just going to be running our test all the time and we'll catch any slip ups. And if any of these cases fail, we'll be able to pinpoint exactly what happened and be able to recover from that. Thank you for watching, and I'll see you next time.